In today's video, I'm going to show you how to create this interactive table all from within R. Look at this beauty, it has a lot of fancy stuff in it, and I'm going to show you how to build this. This is going to be a long and detailed video, so let's dive in. Alright, before we head into our studio to start coding, we should probably check out all of the nice things that we need to implement inside of this table. We have nice bar charts and circles to visualize quantities. As you sort columns, these things transition smoothly. We also have a little interactive line chart that shows you more details as you hover over it. What's also nice is that you have a lot of different icons for all of the different states in this table, and even better, you can unfold all of these rows to see a map that highlights the selected state and also more information about that state. Now, if that isn't a fancy table, I don't know what is. So let's head into our studio to start building this thing. All right, we do have a whole lot of things to cover, so let's dive in right away. In my quarto file, you see here in the first code chunk that I have included all of the packages that we're going to need for creating this table. For now, don't worry about what all of these packages do. Instead, just accept that they're there. The point why I've included them right now is because that way, if we have all of the packages loaded, we can read in an RDS file that contains our final table. And then if we execute this whole code chunk, then we see here that we have our final table in here. My point here is that we can always look at our final table to see where we want to head next. Just to recap what we want to have in our table, we do want to make sure that every row inside of our table can be unfolded, and there is a URL that leads even to the Wikipedia page, and you can also see a map for every state. And inside of the columns, we do want to have all of the information on the state, the capital, the largest city, the number of votes the state has in the Bundesrat, the Federal Assembly, and we also want to have some numeric information on the area of the state and the population in millions or per square kilometers. And also we want to have a nice line chart on the GDP of the specific states. All of these things here are sortable, and you do see here that we get nice smooth transitions when we sort things. For our Spark line chart, we also see here that we have tooltips. So it is an interactive Spark line, and we can see here year-on-year comparison on the GDP. And finally, when we scroll down all the way to the end of the table, we do see here that there is a footer, and this footer contains information on Germany as a whole, whereas the rows just contain information on each state separately. So that's our goal. Now let's check out what kind of data we have. To do so, let me minimize the table for now, and then I'm also going to load a new data set that I do have inside of my working directory. I'm just noticing that I've set my working directory not before loading this. Everything is in the same directory. You can see that here in my fancy Reactable folder. We do have all of the files in here, and I should have set the working directory in this code chunk. It just worked. Anyway, once the working directory is set, and remember to always use relative paths using the here package. Once we have that, we can now load the German stats dataset. And if we execute this part here, then we do see here that we have a whole bunch of information where each column that we see in this dataset basically corresponds to each column that we've just seen in the table right now. This dataset didn't appear out of nowhere. We actually made sure in the last video to get that data from Wikipedia and Statistik Portal to websites that we scraped using the RVES package from R. All of these columns correspond to the thing that we have seen in the final table in here. But there is one thing we should be careful about, namely this GDP column. If I look at the German stats dataset and just have a look at the GDP column, then I do see here that this is a list-like column where each row of our dataset, it has not one value, but multiple ones. And these values will later be translated to the chart that we see in our table. Also, it's worth noting that in this dataset, the second entry is always missing. It is an NA, and that's just because the data that we found online was just structured that way. It always starts in 2015, and then we have 8 entries in total. So that's our data. If we look at this thing again, we do see here that in the state column, we have all of the states. And in here at the end, let me just select the state column. We do see here that the last entry is Deutschland, so Germany as a whole. And we always have to treat this in our table a little bit separately. And I know that you can't wait to start the table. Let me just mention 3 more data sets that we have, namely the state URLs. This one isn't there right now because it is hidden in this code chunk here. It isn't that interesting. It is just all of the URLs for all of the states. And these lead to Wikipedia, which we'll need later on. And we'll also need the state descriptions, which is another thing that we have web scraped from Wikipedia in the last video. Here, just know that it's a character vector that contains all of the information on each state separately. Okay, so you know all of the data sets that we have. I'm sure you're ready to dive in, so let's do that now. Let's create a new code chunk, and then let's start with the German stats data set, and then let's select everything but the last row, the 17th row. Germany has 16 states, so this is why the 17th row in this data set is Germany as a whole. And let's call this German stats without totals. And that's the data set that we need most of the time in this video. And the first step is really easy. All we have to do is to pass this to the Reactable function. And this works because we have already loaded the Reactable package here. So if we execute this, we do see here that we immediately get a table, and the structure of it already looks exactly like the final table. I mean, it doesn't look nice at all, but the structure, it is the same. It is image, state, capital, and so on. We just have to make sure that things look nice. But one thing that is bothering me here is that it's paginated, so I can skim through separate pages in this table, and I do want to have one long table. So this is why inside of the Reactable function, I set the pagination argument to false. So that way I do have a long table now. And with that, we're already ready to make things look nice. The first thing I want to do is to create default settings for each column. And for that, I do use the default call_def argument, where I can use the call_def function from the Reactable package. If you have worked with Reactable before, then you know that this is the typical function, not the only typical, it is the function, the one and only function that will help you define how your column should look, and everything that you want to do related to a specific column can be done via such a function. If you haven't worked with Reactable before, don't worry, just follow along, or you could also check out my intro into Reactable. There should be a link popping up right about now. So the first thing that we can change is the default alignment. Basically, I always want to have the vertical alignment centered. So if I execute this now, you do see here now that all of the entries in my table, they all were center aligned in terms of vertical alignment. But I also want to make sure that by default, things are left aligned. And for that, I use the align argument. And now you see how everything shifted left. It's not like I want to use these settings on all of the columns. I might change some of these default settings later on for specific columns, but for now it is a good baseline. So this is why I set the alignment like this. Also, I do want to change the column names here. They are terrible. I mean, they are nice for programming. They are exactly the same things that we have inside of our table. So these are the column names that we see here. But if you want to create a nice table, you do want to make sure that the column names are also human readable and not only nice for programmers. So this is why I do want to set the header argument to a function that will transform every column label. And here the function that transforms the column labels is string replace all, that takes the column name it gets and then replaces the underscores with white spaces. And once that is done, this thing is passed to str2title to make everything into title case. Now if we execute this, we do see here that we have nicer names. They are not perfect, but once again, they are a nice baseline and we can tweak every label later on if we need to. And finally, I do want to change the style of the column headers by setting the header style argument to some CSS arguments, where I use the CSS functions from the HTML tools package, which we have already loaded, but it's for me just a force of habit to always write HTML tools : CSS. So even though it would work without this part here, for some reason, my habit is to just always write it out like this. In any case, if you've never worked with CSS, I do have an intro on the whole HTML tools package. If you want, you can check that out after this video as well. But I think if you haven't dealt with CSS before, you can still follow along quite nicely because it's really easy. All you have to know is that there are always some attributes like font weight that you set to some value. In this case, you make things bold. In this picture, it doesn't change anything because per default it is bold. But if I were to bring this to Quarto. Quarto might override some styles, so this is why I hard code the bold font weight here. But a more important thing that I want to change is the border at the bottom, and there I set it to a 2 pixel wide solid border that is black, and then we do get a nicer column line. So we do have nice column names now, but if we scroll down, we notice that there isn't this footer, this last row that contains Germany as a whole. And for that, we need to include a footer for every column that we have inside of our table. And the way to define such a footer for every column is to define the footer argument inside of the default column definition. And in there, we need to put in a function that takes the values and the column name of the specific columns. And from that, this function should compute everything that needs to go into the footer of the specific column. In this case, it's pretty easy. This function should just take the German stats dataset and grab one single entry from it, namely the one in the 17th row inside of the column with the specific column name that we're currently looking at. So this function will go through every column that we have inside of our data set, and then it will just take these names here and also the values of each column, but it doesn't actually use this argument. Instead, it uses the column names, and then it uses these names to look into the German stat data set where we have the 17th row that contains the information on Germany as a whole. So if you execute this, then you do see here that we have our footer here. So you see here when I scroll that only the part on top scrolls, the other thing stays constant. But this doesn't look particularly nice yet, so this is why we need to change the footer style by making the same changes as before using CSS. Namely, we want to make things bold, and this time things do change when we make things bold. And also we make the top border black again, and then we can see here that this footer is nicely legible compared to the other rows. Okay, so these were the default changes that we want to apply on every column, and now our task is to go through every column one by one and define specific settings for each column. For that, we need to use the columns argument, so let's set the columns argument, and in there we need to specify a list. And now for the image column, we can specify specific settings using the col definition function again. Let's start off with nice and easy changes like getting rid of the column name. In this case, this image column name, it doesn't really make much sense. Once we have the images in there, it's clear that there is an image. So let's set the header argument to an empty string. And if we execute this, it's gone. Next, we can modify the width of that column. So let's set this to a width of 65 pixels, and everything became a little bit narrower. Now comes the hard part. Now we do want to modify each entry in every cell of this table. Not technically of every cell of this table, but of every cell in the specific column of this table. So this is why inside of the column definition of this column, we do modify the cell argument. And in there, we specify a function that once again gives us back the thing that should go into the cell. In this case, it only uses the current value of the cell and transforms it to something else. So here we have currently the URL to the image that we want to see, and we need to transform it to actually display the image. And for that, we need to use HTML tags that can take a link and then display the image. Because the thing is, everything you see inside of this window here, it's just HTML and CSS. The Reactable package just generates all of that for you. Here you just say, use the image tag. This is something from HTML and CSS, and this tags thing, it is available through the HTML tools package. So with this function, you can now specify the source of the image, and in this case, it should always correspond to the value of each cell, where right now in every cell there is the link. So that's exactly what this image tag needs, namely the URL of the image. And in there, you can also specify the width of the image and set it to 50. And with that, once you execute this, you immediately see that, yay, we have images now. But you also see that right now, the footer, there is no image in there yet. So this is how you know that you always have to treat the footer separately. And we already know that there is a footer argument inside of the column definition. So that is why we know that we have to do the same thing in the footer. where we specify another function that returns the image tag with the URL to the image inside of the image tag. But this time we do have to specify the source specifically, not in terms of the value. So that's why we just say, you know what, in the German stats dataset, in this one here, just take what is inside of the image column. It's a vector, and then just grab the 17th entry, which is the last one, which is the image for Germany, or rather it is the coat of arms for Germany. And just like before, we specify the width to be the exact same thing as for the other cells. And now if you execute this, you see that, yeah, we have an image for Germany as well. Excellent work, my friends. I hope that you are as happy as I am to see that we have images in here now. It always feels a little bit like magic to transform a string like a URL into a nice image that all look the same. They are all of the same width and height, which makes it look really neat and consistent. So let's move on to the next couple of columns. For the capital, the most populous city, and the Federal Assembly votes, there's also not much to do. Really, the only thing that we might want to change is the label Federal Assembly to Bundesrat. If we look at our final image, if we re-execute this part here, we do see here that we wrote Bundesrat, so I guess we have to do this here as well. I can't, of course, execute this part here right now because I have put in a comma here, so it asks where is the other stuff. So once I have the comma in here again, I have to specify the specifications for the other columns. So let me just throw in the things for state, capital, and most populous city. And here is where I meant we don't really have to change anything. I was kind of getting too far ahead when talking about the Federal Assembly votes, because there we really want to change things. We do want to have these circles here, but for the other three columns here, this is where I say, okay, we don't need to change much. We just set the width to a specific value and then we're good. But moving on to the next column, namely the Federal Assembly votes, let's talk about that next. Inside of our data set, we look at it again, we do once again see that our column name is Federal Assembly votes. So let's specify that next. Once again, we use the call def function for that, and we can start out with the easy changes just like we did with the image column. The first easy changes are, as I've just said a couple of minutes ago, we want to have the name as Bundesrat votes, right? We are getting an error because I forgot a comma here. Now if I execute this, we do see here that Bundesrat votes is in there now. And I do want to have this center aligned, and I want to set the width to a specific width once again. The center alignment is just the thing that I do because we want to have circles in here now, and they should be right in the middle of this specific column. Now, before we move on to make the bubbles in here, let me specify a new variable. Let's just call it main color, because I like to set the colors to some variables in case I change my mind later on and want to have everything in a different color. So that's why I first define this in this bluish hex code. And then we can use inside of the cell argument another function that transforms the numbers that we have into something that looks like bubbles. And for the cell argument, we're going to use a function from the Reactable formatter package. You know, this package that we have loaded here. This package is really neat because it has a whole bunch of neat helper functions that make things look really nice, really fast. You can build a lot of things from this package yourself using things from HTML tools, but then you have to set up everything yourself and it just takes more time. So this is why, especially for these things like bubbles and bar charts, I do like to use this package. And if we look at our cell argument again, then we can put in the bubble grid function from the Reactable formatter package in there. If we look into the documentation of this function, we do see here that we need to throw in the data for the circles that we want to have. And it says it needs to be a data set containing at least one numeric column. So let's just throw in a data set that has just the column that we want to work with. So that's why we're just going to take our data set and select the Federal Assembly votes column from that. So if we look at this, we do see that I get an error because I probably wrote, it's totals. Let's just make it into total, then everything consistent with the code I've prepared before. But now we do see here that we have huge bubbles and the colors are also not the ones that I want. So let's throw in a couple of extra arguments into the bubble grid function using the min value and the max value function. I guess it's probably clear what they do. They specify what is the minimum and maximum value, and that way we get to control the sizes of the bubbles here. here. But this doesn't change the color, and for that we need to set the colors argument, which needs 2 colors or at least 2 colors. I'm not 100% sure if you can have multiple colors. In either way, we need to use our main color that we have specified before, and we need to use a lighter version of the same color. So for this lighter version, we're going to use the lighten function from the color space package, and in there just take our main color and lighten it by 90%, and the other color inside of our colors vector should just be the main color as is. And now if we execute this, this looks exactly like we want. And now if we sort this thing, you can see here that there are nice smooth transitions of the circle changing. This is what I mean when I say that the Reactable formatter package has so many nice built-in things for you, because you could really draw these circles really easily, but then when you sort things just might immediately go to the other sides and don't transition as nicely as you see here. So that's why for these visual things, I really do enjoy using Reactable formatter. Okay, so with that, we have covered another column. Time to work on the area, population, and population per square kilometer column. These columns I want to make into bar charts, so I kind of need to do the same thing 3 times. Not exactly the same thing, because things are a little bit different for each and every one. Let me just show you the final image here. Here you see that I have in the final image, I have the bar charts. They all have the same width. And you can see here that the numbers are on top of the bars, and the bars don't fill completely for the area and for the population in millions, but for the thing in square kilometers fills completely. The reason for that is because in the first 2 columns, I do want to show that all the blue things, they are part of a whole, because all of these areas together, they should sum up to the whole square kilometers of Germany. And the same thing is true for the population in millions. So this is why no single bar chart can go all the way to the end. But in terms of population per square kilometers, there's no such order in terms of parts of a whole. So this is why things are a little bit different there. And also notice that the type of number is different. Here I do have the unit square kilometers. Here I just have numbers, but the grouping is a little bit different. Here we have large numbers, or we might have large numbers, and always integer values. Here we do have comma values. So these are slight differences in the way these bar charts need to look, but overall they share the same logic of how to build this. So this is why we're going to build our own function that uses yet another function from the Reactable formatter package. And in the function that we build, we're just going to put in a couple of if statements that checks when you are in the area column, treat values like this differently than if you were in the population column. Okay, so that's what we're going to do next. Let's throw in a new function. Let's do that at the top here. All right, so let's start out by creating a function with the name bar chart. As I've said, it's supposed to be a function, and what the argument of that function is supposed to be is the column name. And the first thing we need is a formatting function. You know, this should be a function that can take any number and make it look nice. For the area, it should format it as an integer and put square kilometers at the end. For the population, it should be a comma number. This is what I mean when I say formatting function. And for that, we can specify that we have this one formatting function if the column is the area in square kilometers. This name here is the exact same name as we have in our original data set, namely this one here. So if we know that we are in the area column, then my formatting function, it should be the label number function from the scales package, because this scales package will give me the exact formatting function that I want. And in there I can specify that it should take any number it gets and put in square kilometers at the end of that. And it should make sure that for large numbers like 1000, 2000 or so on, so everything with more than 3 digits, it should use as a grouping mark a comma. And in all the other cases, it can just use label comma from the scales package. And there I just want to make sure that it either uses integer values when the column is the population per square kilometers, or it uses a comma number that really shows accuracy to 2 digits decimal. Don't worry too much if you're not familiar with this. The point of this is at the end, this is a function that can take any number that we have in our data set. So if we look at our data set and look at, for example, the area column, we do see here there are numbers here, but they won't be nicely formatted if we don't format it nicely. Let's check out how our numbers right now look. See, here there is no grouping marks or whatever, and here there are differently many decimal digits in the numbers. With a formatting function, you can make this look nicer. So once we have a formatting function for every column that we want, we can set the maximum value for every bar. So if we have the column name is either area in square kilometers or population in million, then let me make a little bit more room here. Then we want to have as the maximum value, we want to have the thing that is in the last row, namely the thing that already is the total value, namely the one that corresponds to Germany as a whole. And in the other case, just ignore the maximum value and set it to null. So with that, we have everything we need that we can throw to the Reactable formatter package. Namely, this package gives us the data bars function. And in there, we just have to specify the data argument where we specify that we use our data set, and we just select the column that we currently use as part of our function. So since this column is a variable now, we can't just throw this into select. We have to use any of, but the point is that this thing here just takes the data set and grabs the column that we want. And as you probably guessed, this data bars function has a whole lot of other arguments, like setting the text position. We want to have the text on top of the bars. We do want to set the bar height to a specific number. We do want to make sure that the numbers are formatted nicely. And we want to make sure that the colors of our bars are according to our main color, namely our bluish color. And then we have to also specify the maximum value for the bars. So with that, we do have a bar chart function that can take a column from our data set and transform that into a nice bar chart. So let's just take this thing here, and then we do have to go into the area kilometer squared, and then in the call def function, we can just set the cell argument to this function here. And now if we execute this, takes a while. I can wait forever, it doesn't do anything, because in this function here, we do have to specify that we're currently working with this column here. And now everything works. This might feel a little bit weird because you might think, okay, into this cell argument, we always have to stick a function that does the transformation for us. But the thing is, just like we did before, we had to stick in the function from the Reactable formatter package into this. And we want to do the exact same thing. So this is why we execute this function, because the return value of this function is this data bars function. And this then moves on into the cell of this column. I know it's a bit dumb, but it avoids having to repeat this data bars function a whole lot. If you just execute this bar chart, then you see that there is no return, but invisibly it will return this data bars thing here. Don't know why the Reactable formatter package was built like this with this invisible return, but when you execute this as part of a Reactable, as you can see, you do get a nice bar chart inside of your column. And now you can work on the easy changes again, like changing the header name, lining everything to the left, which is the default anyway. I don't know why I have that in there, but we set the width to a specific width. It didn't change much, but this is likely due to the size of the window that I have here. You do see here that the population columns, they change width, but even though the window gets larger, the area column stays the same, and that's because we have hard-coded the width here. And then you might realize that inside of the footer of this particular column, there is no nice formatting for this number. And that's because we've never specified a formatting function for this. So this is why we define a new footer function. And in there, we just grab the last row from our data set inside of the area square kilometers column, and then we passed it to label number again, just like we've done before. So that way we do have nice bar charts here now with a nicely formatted footer. And even though this part was complicated, I know it's not easy to follow along if you've never done this before, because there are so many moving parts. But even though this wasn't easy to digest, now that we have done it once, we can do the exact same thing for the other columns here. Let me just take this part here and repeat this twice. And in the first copy, we can change the column name to population in million. We have to specify that we use that column in the bar chart. In here, we have in millions. Let's just throw this alignment out because we don't need this at all. The width stays the same. And we also have to make sure that in the footer, we use the correct column. And here we replace this thing with the comma function. And that way, this whole thing will be nicely formatted using a comma number. And then we have to do the exact same thing for the third column. And here we have to put in per square kilometers. We have that abbreviation up here, so I don't need to write it out. I can just copy it. Here we have to use the same column again. In fact, for this one, we don't even need any formatting because this is already in the format that we want. So let's just throw out this footer function in here. Now, if we execute all of this, then of course I have missed an argument here. It is label comma that I want to use here. And now everything looks like we want. Nice. With that, we have 3 equally sized bar chart columns, which I think is pretty great. And now we have to focus on the GDP charts here. This time though, we won't use a function from the Reactable formatter package. Instead, we're going to define our own function that creates a ggplot that is interactive using the ggref package. So that is why here our code is getting really long. It takes a whole long time to scroll up. But that is why we do have this ggref package here so that we can create our own plots and make this interactive. So let's create a new code chunk here and define a new function that creates these line charts for us, which are also in the context of tables often called sparkline. So that is why we create a function that we call sparkline. And in this case, it needs to be a function depending on 3 arguments, namely the value, the row index, and the column name. Actually, I don't even think that our function will use the row index and the column name. We might not even need to use those. Let's build out the function first. And then if we don't need it, we can just stick with value, just like we did in the previous self functions as before. The thing with Reactable is that sometimes you need to use a function that only takes the values. Sometimes you need to write a function that also takes into account the row index and the column names, depending on what you need. And I do think it might even turn out that we only need the values here. Let's fight that battle when we get there. For now, let's just build out this function. But before we do that, let's have a look at our final image again, just to see what we want to have here. In our final image, we have a nice chart with tooltips, okay? The tooltips is a bit tricky, so let's for now not worry about those, but we do want to have a nice shaded background that starts at the 2015 level of the GDP and then always highlights the differences here. And we do have points where we could draw points. Remember that between 2015 and the 2017 value, there was always a missing value in here. So this is why we do have points and lines separately here. So they are not all connected. So that's what we're going for. Let's build our sparkline function now. First, since this function only gets the values, we also need to define the x-axis properties. So this is why we specify that the years are always from 2015 to 2022, even though the value for 2016 will be missing. Then we can create a static ggplot using this value vector. So we're just going to define a mapping like we normally would, using on the x-axis the years vector that we have just defined. And then on the y-axis, we use the values that are submitted to that function. And then we can start out with the shaded background. And I use a GM ribbon where we have to specify the mappings, namely the x-axis should be everything but the second entry. And the reason for that is because I want to skip this NA value because GM ribbon should draw a straight line from the first value to the third value. So this is why I leave out the second entry here. And then for the Y aesthetic, GM ribbon doesn't use that. So we have to set this to null. Otherwise it will complain because we have specified Y in the top layer. And then we specify that the minimum value is 100, the baseline of the 2015 year, and the maximum value is the things that are submitted through the value argument, but leaves out the missing value again. And then we can specify a whole lot of transparency because we want to have a shaded region here. And we want to make sure that we use our blue color. And then on top of that, we draw our line. And there we just have to specify things like the line width and the color, because the line can be drawn just using this years vector, the value vector. And then on top of that, we throw in the points that we also only have to customize in terms of the color that we want to use, the size that we're supposed to have, and the fact that missing values should be removed. And with that, we have mostly built out the static plot, but there's one thing we have to take care of. You see the charts in here, they are all built individually. This means through this sparkline function, they get the values that only concern one row of the data set. But since they are supposed to all share a common axis, we have to tell ggplot that for each of those plots that you generate, make sure that you use the same axes. For the x-axis, it's always the same because we hard code that anyway, but for the y-axis, we have to tell it what to use. And for that, we use the scale y continuous layer, where we set the expand argument. Don't worry too much about this, it's just to give a little bit of padding around the chart. But the more important thing is that we set the limits by taking our data set, looking at the GDP column. And since this is a list of vectors, we first have to unlist these things. And once we have that, we can use the range function to calculate the minimum and maximum value of this. And here we see that we get NAs because NAs are in here as well. So that's why we set NA remove to true. And that way, once we do that, we do get a range this time. Make some room here. And that way we have made sure that the axes are always the same for every chart. Now this thing here is a static plot, but we do want to have an interactive plot. So this is why we need to transform this thing into something interactive. So that's why we have to save this and then use the gref function from the ggref package to make this interactive. So let's save this into a new variable, and then we can use the gref function to pass in this gg object into it. And that way we have just taken this static plot and made it interactive. But if you know ggref, you know that you usually want to have a gm line interactive or gm point interactive, some interactive layer. We don't have that yet, but here we use the gref function only to make sure that the output of our sparkline function isn't a static image that ggplot produces, but a nice interactive HTML document that gref produces. So even though we don't really do anything interactive here, we still use gref to make sure that what we put into Reactable is actually something that Reactable can handle, because it needs some HTML stuff that gref generates for us. So with this function now, we can go into our column definitions again, go all the way down, and then let me just throw this whole thing in here. And here we use inside of the header, we use a little bit of HTML and CSS to generate this smaller text in here. So if we just take a look at this part here, this generates just HTML and CSS. I'm just moving along a little bit faster because this is already getting quite long, and I do want you to get the important parts and not all of these mundane details that you can probably follow along already. In any case, we can now throw into the cell argument our sparkline function that we've just defined. And we have to make sure that inside of our footer, we also use the sparkline function, but there we want to make sure that into the value argument, we do throw in the data for Germany as a whole, and we do specify the width here again. These NAs here are just there because the sparkline function has these arguments, but since they are NAs, we know that we don't really need them and we have never used them here. So let me just throw this out, and then things are even more obvious. This part here just uses the values that we pass to it. So we have to, so if we execute this part again and then execute this part here, we do see here now that we do get a plot, we get a whole lot of GG plots, but there is obviously a whole lot wrong with this. For starters, we do see here the grid, and the reason why we see that is because we forgot to add a theme void on top of that. So that's one thing we can get rid of. But also the dimensions here are not really nice, and this is where the gref function comes in. And in there, we specify the width of the output. Let's set this to 16. And we also specify the height. And let's set this to 4. And then also, if we look at this, you do see here that there's always this download PNG button that will download a download screen for you. And we don't really need that. And we can deactivate this using options. And in there, we put in a list and set the ops toolbar options to save as PNG false. And now if we re-execute this function here and then re-execute our Reactable code, then we do see here that we get a nicer chart. There's a bit too much padding here, so let's just reduce the values here. Still too much, let's just go with 1%. All right, so after a short debugging session, I set this padding to 0.1. And more importantly, because as it turns out, when I prepared this, I forgot to add this NA remove as true. And that's why my chart actually made the mistakes that I want you not to do. So now that I have coded this in this video, I realized my mistake. So that's why the numbers here had to change, so that's why I changed the height of the chart to 9. The problem that we've had before when we have only 4 here is that the height isn't large enough to actually show a whole lot of things, because as it turns out, Berlin had a really strong increase in GDP, and that's why all the other things look flat. But if we do make the image a little bit larger, then everything looks nicer. Then Berlin still has this large increase, but we can also make out some of the details of the other states. Nice. So while doing this recording, I found this little mistake. So I guess this video was a nice quality assurance. In any case, we do have our line charts here now. Now the thing that is missing is the tooltips. Right now, we don't have any tooltips in here because the thing that we have specified here is purely static. So what we need to do here is to throw in a GM point interactive and map a tooltip static to some values that are to be displayed. For that, we first need to calculate the year-on-year change, because in our final chart, this one here, it still uses the wrong y-axis scales in here, but the tooltips are still correct. For this chart here, we do see here that there is a year-on-year change that is displayed, so we need to calculate this first. So in our spark line, we first need to use our values and calculate the year-on-year data. So what you need to do to calculate the relative difference is to take the values as is and then divide them by the shifted values, where you shift all the values by 1. So if you have a vector, let's call it 1, 3, then you see here this 1, 2, 3 vector is shifted by 1. And then when you divide these things, you do get the relative change. You do get another vector, but you have to subtract -1. Otherwise, you don't see the change from year to year. If we look at our example here, we throw this in there, you'd see that this is 2 because the value doubled, but the increase of that is 100%. So that's why you subtract -1 to see this part here. Anyway, that's how you calculate relative differences if you didn't know that before. And depending on whether these relative differences are positive or negative, so if the GDP rose or sank, we do want to use different colors for the text that we display later on. But before we do that, we also have to make sure that this NA is treated properly and that the numbers that we have here are converted to text. So that's why we create a new variable called text, where we use the if-else function to check whether the calculations that we've just done yielded a missing value. If that is the case, then we just make it into an empty text. And in the other cases, we use the % function from the scales package to make the numbers that we have in here into nice formatted % labels that use the same accuracy all the time, namely with 2 decimal digits. And as for the colors, we can do the exact same trick as we have done here. We can just calculate a new vector that we call text color and check whether what we have calculated, when that is less than 0, then we use this red color, or if it is positive or non-negative, then we use this green color. So now what we have to do is to put all of these texts that we see in the box here together. And that's a bit tedious, so that's why I will skip over it. If you want, you can look through the code and check out all the details. Here there's a whole lot of extra cases you have to cover, because in the first 2 years you cannot show year-by-year data, and then you have to throw things together. So this is why here I will just skip over this. Let me just throw in the code for that generates the vector full of these texts that we see in the tooltip here. So just assume inside of this vector is the text that we have in the boxes here. And now all we have to do is to throw this into GM point interactive. And in there we have to specify the tooltip aesthetic and set that to the text that we have just calculated. And now if we re-execute this code so that our function is loaded, we can also re-execute our Reactable code. And now we do see here that we have tooltips now, and we do see that we have the text already, but the tooltips don't look quite right. But this one is really easily fixable. But the point here is that the texts, they look correct, which is great. This is the most tedious part of this whole function. To create a nicer tooltip, all you have to do is inside of our list of options, inside of the grep function, you have to throw in the opts tooltip function. And in there you can specify some properties like the opacity. You do see here that the box is a little bit transparent and might be hard to see. Oh, here it is. visible much better, but I do not really want that. I want to have no opacity at all. So this is why I set this to 1, or rather I don't want to have any transparency. So this is why I set the opacity to 1. And then we can also throw in a whole lot of CSS customizations. And for that, the gref package provides you with a gref CSS function where you can throw in another set of CSS instructions using the CSS function from the HTML tools package. The point of this gref CSS function is that you can throw in different kind of CSS instructions depending on the geometric object, whether it's text or a point or a line. Here we just throw in the instructions that we want to add into the all-purpose CSS argument. So that's why we have this nested structure here. Either way, we can now list all of the things that we want. And if we look at our final table, scroll down here, then we do see here that we have a white background with black text, and we have a whole lot of padding around the text. We have a box that has round corners, and the border of this whole box is blue, and all of these things can be specified with CSS quite easily. So as for the text color, it's just a color attribute that you need to set. For the background, you just set the background argument. For the padding around the text, you set the padding argument. So this way there is some room between the text and the border of the box. You can specify the font size and the font family, and you can also set the border that you want to 2 pixels solid, and then we want to put in the main color that we have inside of our variable main color, this color right here. With glue, this string is assembled like this, and then it is put into the border argument. And finally, we can set the border radius to 5 pixels to make sure that the box has these nice rounded off corners. And now if we re-execute this function and re-execute our Reactable table again, then we do see here that our tooltip looks exactly like we want. But that was pretty hard. Congrats if you've made it through this. I know this is really a lot. There are so many details you have to style if you work on a table like this, but I do hope that you get a whole lot of value seeing me work out all of these details. In any case, just to relax, we can finish off our table here, or at least this part, by doing a couple of easy changes. You see in our final table, let me load that again. You do see here that there is a group. These population columns are grouped together, and we can really easily make that happen by using the column groups argument and listing all of the groups that we want. In this case, we only want to have one set of grouped columns. So this is why we only have one column group in here that we name population, and we use the population columns for that. If we execute this, we now see that we have this grouping that we want. And then finally, another really easy change is the changing of the font family. You see, you can specify a general style, and you can use the CSS function just like before. Here we'll just specify that the font family should be Source Sans Pro, and that way we do use a really nice font compared to the standard font. So as I've said, really easy changes this time. And now the thing that is missing compared to the final table, let's have another look at it, is the thing with the foldable rows. But the only hard thing about this is assembling all of this part here. Making this foldable is really easy once you're able to make this text and to make this map. And once we have that, we can also add the title and subtitle, which is at that point really easy then. So with that said, let's work on the maps next. Now to create the maps, let us scroll all the way down to our code, and in there, or rather right before we have this long code chunk where we have all of that table code, let's throw in a new code chunk where we throw in the stuff for the maps. For creating these maps, I'm going to use a package called GiscoR, which I have described in a whole bunch of detail in another video, which you can check out when you follow the link that should pop up right about now. So that's why I'm just going to throw in this code here, which loads the GiscoR package and then gives us the state data of the German states. Let me just execute this, and then you'll see that this just gives us 16 rows for the 16 states that we have in Germany. And then we have things like the name, and there is a geometry column. And with this geometry column, we can use ggplot to create a map like we have here. So really this GiscoR package just gives us the data for the German states. And as I've said, if you want to have more information on all of this code here, all of that is documented in another video. Now let's look at the German stats data set again, and let's look at our first state in there. So here we have Baden-Württemberg, and let's save this into a variable called selected state. So now what we can do is take this data set here and then pass it to ggplot, where we specify the aesthetics. Namely, we have to map the geometry column to the geometry aesthetic and the fill aesthetic to whether the thing that is in the name Latin column is the same thing as is in our variable called selected state, which we can see once I've executed this part here. And now creating a map is really easy. All you have to do is to throw a GMSF layer on top of that, and now you'll see that you already have a map. And just like we wanted, we see that the state that we're currently looking at is highlighted. And to make this chart a little bit nicer, we just have to throw a theme layer on top of that to get rid of the legend. And then we can use the scale fill manual layer to specify a couple of specific columns. Namely, for the trues, we want to have our main color, and for the falses, we want to have this gray 50 color. Clearly, we also want to get rid of the coordinate system, so let's throw in a theme void in there as well. And now to make the states a little bit more visible, let us specify the color to be white. This will give us the outlines, and we can change the line width to something like 0.75. Now this is a static ggplot, which means that this is just an image file basically. So we can save this image into a new variable, but to get this into the HTML format that Reactable has, we need to convert this. And for that we can use the gref package. Into the gref function, we can stick in the plot object that we have just saved. And now you see that things open up in the viewer pane instead of the plots pane. You see the difference. But you also see that there is this download button up here that helps us to download this as a static file, which we do not want. So inside of the options, we can just make this go away. So let's set the options, and this one needs a list. And in there we use the opts toolbar function to set the save as PNG option to false. And now if we execute this, we see that this button is gone. And now we know that we can create HTML compatible maps really easily for each state. Really all we have to do is to repeat this code part here for all of the states. And since we've already made the state variable via a variable called selected state, we can just take this part here and throw this into a new function. Let's call this function create state map, and the variable that it needs is selected state. And then we'll just throw in the code that we have just used. And now this function can do exactly what we want. Take this code here. See that we get the exact same output, but of course we can do that for other states as well. And you see how we go through all of the states one by one. Next, if we look at our final table again, we'll see that not only do we have a map here, but we also have descriptions here. And if you recall, we also have a vector called state descriptions that has all of that information that we see inside here stored as a vector. So now what we have to do is to combine the map with a text. So let's scroll down again. And now let's focus on putting next to each other a map and a text. For that, we can use a little bit of HTML and CSS magic. First, we create a div and we can throw it to the browsable function so that we can see the output of the containers that we create. Now, inside of this div container, we want to have two more divs, which are just placeholders for where we can put in stuff. In one of those divs, we can just throw in the map that we have just created. Let's just take this map here as an example. And if we execute this, we see here that, okay, we have the map in there now. Let's also fill the other div with some text. For that, we can look into the state descriptions and use the corresponding index that we've also used here. You know what? Let's throw this into a new variable. Let's call it row index. And then we can just replace this stuff here and we don't have to do it manually all the time. So now we see the map here and we see the text below that. That's not particularly nice, so we do have to figure out how to put these things next to each other. One way to do that is to modify the style of the outer div container so that it uses grid display. To do so, we're just going to set the style attribute to the CSS function from the HTML tools package, and in there we can just specify things like the display should be a grid display, the template for the grid should be 2 columns, where the right column is 2 times the width of the first column, and then we also want to have a gap between rows, and we do want to have a heading. If we execute this, we now see that things actually worked out. But now that I think about it, this row gap here doesn't change anything because we have 2 columns and no other rows. So let's just go with this here. All right, so that's cool. We can do the same trick with the second div container and throw in some style instructions. Nothing too fancy, just making sure that the font is nice and the font is larger. Now, if we look into the final table again, let's just re-execute this part here and we take a look at the text here, then we do see here that there's also a link to Wikipedia in here. So this is the one thing that we need to take care of as well. So let's scroll back to our code chunk from before, and then we have to modify this part here. Since we want to throw in more text inline, we just wrap all of these things into a span tag. And in front of our state description from before, we'll just throw in an A tag, an anchor tag, which can have a text like from Wikipedia. And then if we execute this, you see here that I used the wrong quotation mark, so that's why my console was stuck. But now if I fix this, we do see here now that there is this from Wikipedia in there, but it is not actually a URL right now. For that, we need to specify the href attribute, and for that, we can use the state URLs column that we have. It has all of the URLs to the Wikipedia pages of the URLs, and we're just going to use the same row index as before. And now if we execute this, you do see here now that this is a link, and if I click on it, I do get redirected to the correct Wikipedia page. Finally, to make this look nice, we can once again throw a little bit of style using CSS on top of that. Namely, we just change the text color to the same color as all the other colors. We get rid of this underlying of the URL and we make this bold. So nothing too fancy, but after making these changes, it looks much nicer. Sweet, and now if we change the row index to say 3, we can generate the exact same thing for different states in Germany. So you can probably guess what we're going to do now. We're going to take all of this stuff and wrap this into one function that creates the state details for us. So let's create a new function and let's call it state details. I call it details because I'm going to use it in the details argument in the column definition of a reactable column. So that's why it's called details. And this also explains why we need 2 arguments for this function, namely the row index that we had before. And we also need a column name because this details function just wants to have a 2 argument function. So that's why I just throw this in there, even though we don't use it. And then we can stick in the code from before. And if we re-indent everything, then it looks much nicer. And now we can just call our state details function with a row index. Let's just do 1 and then an empty string just to fill this argument with something. And that way, of course, we get the exact same result. Can use a different number. Hamburg is quite a small state, so let's do another one. And here we see that apparently there's something going wrong with the description of the 7th state. Let's just look into the state descriptions, and in there we use the 7th entry, which is empty right now. Probably that's related to some web scraping issue, but this shouldn't bother us too much here for now. More importantly, we should focus on getting this into our reactable table. To do so, we have to jump into our columns, and inside of the image column, we have to specify the details arguments. So let's throw in details in here, and in there we can just stick in the state details functions we have just specified. Now if we execute this, takes a while to render, but then we do see here now that we have the descriptions inside of our table now. And if we click on the image, then you'll see that all the things are there. But you can also see that this arrow here is kind of not in the right position. So let's make this a little tiny bit larger here so that the arrow has a bit more room for the image. Maybe let's go with 100. And now you see that there's enough room and that this arrow I said, but it's more of a triangle, that this triangle moved down and now it looks much nicer. So with that, we have our table, but it doesn't have any titles yet. So let's save this as an intermediate variable. Let's call it table without titles. And now we can create a new code chunk where we take this table and wrap some titles around this. At this point, this is probably really easy for you because it's just the same trick that we did with assembling the map and the text in the tables. We're just going to take a div container, and inside of this div container, we're going to use the variable we have just defined, namely the table without titles. If we throw this in there, everything looks, well, it doesn't look like we want it yet. We have to throw this this into the browsable function again. Then we see that we have our table, and now we can throw in other containers on top of that to specify titles. So we're going to throw in a div container for the title and one for the subtitle. For the title, we're just going with Germany's 16 states and numbers. So with that, we do see here now that there's the first title. And for the second title, we'll just go with the description of where we got the data from. And now we have that second title in there as well. But of course, this doesn't look particularly nice. So we just throw in a couple of style instructions on top of that, like changing the font family, the font size, and the boldness. And then you immediately see that it became much nicer for the title. And for the subtitle, we can do the exact same thing. Sweet! With that, we have finished our nice interactive table that has a bunch of extra details, and it has nice fancy visual elements with nice transitions between the sorting, and also even interactive charts that make this table really informative. And I hope you enjoyed creating this table with me. I know that this video was really long, but that just goes to show how much effort it is to show you all of the details for you to get this right. But I think now you have a nice set of tools that you can use for the challenges that you might encounter in the wild when you try to create your own fancy table. If you enjoyed this video, I'm very certain that you're also going to enjoy some of my other videos, or if you're even interested in finding an R course, then you can follow this link here, which leads you to my data cleaning masterclass that will help you get better and faster at data cleaning. So now that all of that is said, all that remains to say is thank you for watching, and I will see you next time.